in previous sentence, I just look at the label context. For the given sentence, we are just defining relevant labels, to which labels this is going to classifying. Now I'm going to define pre-trained tokenization. The first step of the pipeline is to tokenize our input text. Okay, so I'm going to define these terms. So to do this, we want to import the auto tokenizer from the transformer package. Next, we need to specify the model we want to use. So I'm going to import relevant transformer here. So just importing this cell and just running this cell. This will ensure the tokenizer tokenizes in a way that is suitable for our intended model. Different models will have slightly different ways of creating their tokenization. So we are going to specify our model and we will use BERT based uncased token. But before this, what is auto tokenizer? So auto tokenizer is a special class in HuggingFace transformer library. It helps you to choose the right tokenizer for your model without knowing the details, because we know there are several kinds of tokenizer as well. So think of it as a smart assistant that knows which tool to use for this job. So the tokenizer is easy to use. You don't have to remember which tokenizer goes with which model. So I'm going to use this certain model. The model name is BERT based uncased. So I'm going to use this model and going to provide tokenizer for the auto tokenizer. I'm not going to define any specific tokenizer method or module, rather it's automatically defining my module there. And I'm going to define this term. So I'm going to define a sentence. Using this sentence, I'm going to first pre-process this text. So I'm going to exercise to be learning about, for example, Teleperformance Private Limited. So this would be relevant sentence, and this is unstructured data set. And I'm going to provide this tokenizer. What is the tokenizer here? This is going to define, this tokenizer method is defined here. This is auto tokenizer, and this is automatically defining what your model without knowing the details. It's going to choose the right tokenizer for you. So I'm going to parse this model in this context. So here you can see this is providing all the inputs and all the values and converted into numerical values. Once it is defined here, you can go back here and you can tokenize in the next term. Can you see it's just defining the next term value? Okay, this is going to define this tokenized sentence, and I'm going to print this token so that I can see this is the relevant tokens. Can you see it's defining? I am so excited to be learning Teleperformance and Private Limited. It just defined it into word tokens. Okay, I don't know what's the name of this, but I'm guessing this is the word token because it's based upon words it's defining here. So you are sure, I'm sure you are keen to get started with other terms. For example, these tokenization, these tokens are then converted into numerical values based on predefined vocabulary specified to these models. So I'm going to convert this models. Let's print this term so that we can see the numerical value of everything. Can you see these terms, these words are converted to numerical values so that we can ingest to relevant predicted models, machine learning, deep learning, or other things. Now I'm going to provide this tokenization and decode. If you want to decode, you can see this token, this word is decoded, these integer numbers are decoded back to our world. So I'm just decoded this part. This is just verification. So this is special token for beginning the space there. For example, I'm going to provide something, for example here CLS. So what is CLS here? This is just first one. So can you see this is what? This is just first CLS there. Okay, so this would be my first token there. If you will check the token number, for example, I'm going to check another token, so it will be giving this value. For example, I'm going to provide this value 2. So can you see this is giving SEP? So what is this? SEP is a separator. So here we can see two things. First one is the CLS and second one is the SEP. So I'm going to copy, control, making a new cell here, print it here and then run. Can you see two things are showing here? First one is CLS, second one is the SEP. So what is CLS and what is SEP? This SEP is a special token for separator. The CLS token is usually placed at the beginning of the input, and SEP token is used to separate different segment of text. So the mask token is used to task related to masked automatic language modeling or text generation, write a blank to fill in. For instance, if you are using the model for translation, you might have a special token like source and target to indicate the source and target language, so respectively. So these tokens help guide the model's behavior during translation. When you feed multiple sentences of varying length into model, you may need special tokens for padding, which is where we add extra token to make sure all the inputs are the same length. Okay, let's go back to the next part of this code. So I'm going to define the next code. I'm going to create a model. This would be model name. I'm going to let's look at how XLNet, another large language model, differs in its tokenization. And so let's specify our model as XLNet based model. So I'm going to define tokenizer as auto tokenizer as we have done earlier, and going to convert my sentence into tokenizer. Can you see it just defining this one? Let's print out input of these values. I can see all these values this here, and let's print out these terms also. What kind of terms we are obtaining here? Here I am going to print everything. Can you see? Let's look at this. Look at how this model tokenizes differently to the BERT model above. We will run tokenizer to.tokenizer over our sentence. When we print this out, you can see then that even just the way that this model has tokenized, the text looks very different to what we saw above. We can then convert these tokens to their ID values. So we will use tokenizer to convert tokens to IDs over our tokens. And when we print this out, you can see that the numbers given to each of these tokens differs again from BERT model above. You might also notice that where the BERT model started the input ID with the CLS and special token, XLNet start with this underscore only. Okay, so here you can see the difference between the model in between these two. So I'm going to convert this value into token to ID. Can you see this is showing convert model? If you want to decode this one, you can decode this value. This is showing separator. So 0, 1, 2, 3, 4. So this is just separator because we had might be two different terms. If I want to decode anything, this is showing CLS, which is showing here. So what is CLS here? This CLS is just classification, beginning of the sentence classification. Okay, so everything having a own module. Let's import some PyTorch model here for the same sentence. I'm going to import this PyTorch for this ease. I'm going to use my sentence and going to define input IDs. Can you see this is my sentence in unstructured format, and here I'm going to use my define IDs, and also using the auto tokenizer for this pre-trained model. So this will take few minutes. If you are ingesting very first time, you are loading in your sheet very first time, this model will take few minutes as well. So this is the reference link. You can go back here for the further classification for this model. Now I'm going to provide tokenization, and this is going to provide this value. So then we will use our tokenizer over our sentence, and we want to specify return tensor equals pt. This will return our input IDs as PyTorch tensor. We can print these output to check it has worked or not. So I'm going to print this module. So I'm going to print this statement. These are all IDs as well. Can you see this is also showing tensor, so that we can go back with the deep learning or another complex models there. So I'm going to use auto model for sequence classification, and then I'm going to use this text here. Can you see? We then want to return label of positive and negative for our input text. Okay, so we will get our predicted class ID, and to use this we will take argument argmax items, and then we take our model config.id to label all this predicted class ID. So I'm going to run this cell. Can you see this is showing positive, means my sentence is bit positive. If I will use the another sentence, any unstructured data set, this might be negative or neutral there. Let's save this model. If you want to save this model for further use, you can go back here and you can save this model also. So I'm going to save this model, and this will create a folder with name my save model, and I'll be using this save.pretrain terms. This would be model triggered. So can you see this is just saving in the format of JSON formats. So let's you can see this is just tokenization, and just I'm going to save this model as well. So this is going to save everything here. Now I'm going to use, if I want to use this one, let's say, now I can see you how this model is saved in my Jupyter notebook. Can you see this is the notebook, and why it was showing the error? Because I had already saved this model earlier with the same name. So I just changed that name with just applying this underscore. You can go back to this. You can see this would be my saved underscore folder. Inside this folder we have all these models and this JSON format, tokenization, and their metadata itself. So I'm going to save this model here, and if I want to use this my tokenization, so I can use this term as well using this model directory, and I can use this term as well. If I want to use the same model, I can go back here and going to use this model directory underscore, so that we can utilize this model again. So what we have done, we had just focused on this hands-on for using the auto tokenizer, using pre-trained tokenizer from HuggingFace transformers. Then we converted everything into relevant tokens. Then we used the excellent based. Then we used the HuggingFace with PyTorch and TensorFlow. And then we have discussed general, not specific, what kind of models you can, how you can save these models, and you can reuse these models. Let's see in next video. Till then, keep learning, keep growing. Thank you.